Hi, and welcome to TEMEKO. In this video, we will recall what is the definition of a free body diagram, where do we use it in mechanics, and how to carry out the procedure for drawing a free body diagram of the observed object correctly. Let us get started. Some of you may remember from your earlier studies, a free body diagram is used to take into account all the known and unknown forces and possible moments that are applied on the observed object, which can be a particle or a rigid body. So as you see, a free body diagram is simply a sketch about the object with all the externally applied forces and moments drawn on it, and in which the object is isolated from its surroundings or its supports. It is very important for you to know how to sketch a free body diagram, because most problems in mechanics cannot be solved without this knowledge. This knowledge is especially used in those kind of problems which are based on the equations of equilibrium. Now that you know the definition and the importance of a free body diagram in mechanics, let us move forward and learn how to construct one. Usually the following 3 steps are required. In the first step, what you should do is to isolate the object from its surroundings or remove it from its supports by drawing outlines of the object. After this, you can indicate all the active forces and possible moments which are being applied on the object, and all the reactive forces and moments which are created by the constraints or the supports. The final step in this procedure is to check the forces and moments that have been drawn using the proper directions. You can also label the known forces and moments with their magnitude if you want, but this is not required. Instead, you can use the letters which have been used for unknown forces and moments. After the free body diagram of the object has been drawn, you can start to create the equations of equilibrium from which you can determine unknown quantities such as force, moment, distance, or angle. Let us present one example so that this becomes clearer to you. Imagine an elevator which moves with a steady speed with a traveling passenger in it. There are 3 forces that are being applied on the elevator. The elevator's own weight, WE, the weight of the passenger, WP, and the driven force, T, which is provided by the cable. Notice that we have made some simplifications such as neglecting the air resistance and the weight of the cable. We have also assumed that the cable cannot be stretched. We can simplify this case even further by indicating the elevator's own weight and the passenger's weight as a combined weight, W. Because the elevator is moving with a steady speed, it is held in equilibrium by its own weight, which must be equal to the driving force of the cable. If we draw the free body diagram of the elevator, the reason for this becomes clear. The diagram shows that there are only 2 forces acting on the elevator which are previously mentioned: the total weight of the elevator, W, and the driven force of the cable, T. Because the elevator is in an equilibrium state, the resultant of these forces must be equal to 0, so T equals W. The point that you should get from this example is that after drawing the free body diagram of the elevator, we know what is the magnitude of the unknown force, which could be either the weight of the elevator or the driving force of the cable, depending on the problem, that keeps the object in equilibrium state. Some of you may think that in a problem like this, drawing the free body diagram of the object is not really needed because it is crystal clear what is the unknown force that keeps the object in equilibrium state. And I would partially agree, but keep in mind that this was a very simplified example. In the real world, we need to handle more complex situations, of which we will practice solving some in this course. In these cases, drawing the free body diagrams is very useful. Hopefully, after watching this video, you remember what a free body diagram is, why it is important in mechanics, and you also know how to carry out the procedure for drawing a free body diagram yourself in different problems which are related to mechanics. Thanks for watching, and have a nice day.